Good morning, everybody. I am today so happy to have such an amazing guest. We met like years ago in a wonderful event. Actually, it was the first DrosoAfricia event performed in Tunisia. It was like 2 or 3 years ago, and actually, I really loved the guy. So, Ross Cagan, Ross, good morning.
Good morning. Hey, we have the Mutual Admiration Society here.
Yes.
I've always been a big fan of yours, Rocco. It's such a privilege to be here. Thanks for inviting me. It should be great.
Thank you, my friend. Thank you. So maybe Ross, for the people who don't know you, who is Ross Cagan?
I guess there are layers to that. So, but for this discussion, so I'm a flyboy from way back. So I was born and raised in the U.S., specifically New Jersey. Went to college in Chicago, PhD at Princeton, and then I studied in LA. Then had my first job in St. Louis, second job in New York City, and a year and a half ago came to to Glasgow. The Regis Professor of Precision Medicine, which is amazing. And basically flyboy who's a geneticist, and our lab uses flies to get at disease, mainly cancer, some rare genetic diseases. So I guess professionally that's who I'm at. And I should say, wife who actually is co-running COVID testing here in Scotland. So she's amazing. And two daughters who live in New York City in their 20s. They're also fantastic. So shout out to them. So I've been lucky.
Okay, lucky you. Ross, you said that you are a flyboy. So maybe to make people dream about this, why fly, and what can we do with fly in research, basically, and what you are doing with fly?
Yeah. Of course, the answer will be what we do, or at least the perspective we have. So flies, I think, flies are interesting. They've had an interesting history. They really played a fundamental role in our understanding of developmental biology, signal transduction, cell biology, and all of those things. Really now you can apply those to disease. But personally, I think if you were to take one thing that would sort of, in my mind, launch the future of Drosophila, what I think where it sits in a special place is it is simple enough and fast enough to handle big data. Okay, so big data is, I think we can all agree, where a lot of, not all, but where a lot of science is going. And so you're awash in all these pathways and networks and all of that stuff. And then, full stop, you have to take, a mammal, and you have to model it. If you want to do things whole animal, what you can do in mice is getting impressive. It's still not flies. We make 12, 15, even 18 hit models in flies quickly at the speed of patient treatment. That's just going to be hard to do for a while. So bottom line, I think that flies have a special place in their ability. They're complex enough to model disease in a way that's useful, but you can still handle the fire hose of data that's coming in. So for me, that's where I think the future of flies and disease lies.
Yeah. So maybe if I can add something here, because I was doing some basic research on cancer here. If I can compare maybe with mice, because sometimes we reach until 2 years of work just to have one single step using mice, but just to make people really understand. So with fly, I think it's like 1 week to 2 weeks to add some stuff. No, just correct me if I'm wrong.
Yep, you're there. Yeah.
So the difference is huge, and we can really do a lot of stuff with fly in a rapid way, as you said.
Well, let me toss in something sort of quick in between, which is the community aspect of Drosophila, which I think really has to be acknowledged. So famously, it's a very open community. It has been very open-minded in welcoming all groups to it in a way that's probably been faster than most others, which I'm happy to be part of, meaning I'm proud to be part of that community. So that all has to be acknowledged as well. And so I feel good about being part of the Drosophila community. And that's important. And I think in recent years, people have begun to recognize that science is done by human beings and they have to be treated with respect. And I think Drosophila has that. They also famously can be tough. They have very high standards. We have very high standards. Yeah. I think that's also good. And I think the reason for that is because flies are always, trying to make sure that they have a place at the table. And to do that, you always have to justify, okay, why this little fly? So the demands for doing things at a high level has always been there. And again, I love that because when I wake up in the morning, I want to feel like I'm getting up and doing something important. Now here comes the fly part. Okay, so far it's been, the Ross and team part. So how are you going to model all that complexity of a patient, not do it in cells because that doesn't capture all the stuff in your body that's interacting that we know is important. Everybody understands is important, but nobody can do anything about because it's too complicated. And we basically, I brought in people who were experts like Peter Smybert, who's experts in RNA splicing and stuff, and he figured out how to make a single construct that can knock down 12 genes. I mean, all these people with all this brilliance. Aaron Bangi figured out how to get all the pieces together to happen. Anyway, I could go on all the people who did this, right? I mean, I met genetic counselors. I didn't know these people existed. I didn't know we needed them, right? And but the core of all of this was the ability to make a 15-hit fly in weeks, so that the patient would be alive by the time we finished it, and then screening those with robotics. So if you push the flies, you can do crazy things. This is all big data. This is all genomics, but big data done fast at the speed of patients. Put into that fly, screening done, getting back to the patient, treating them. I would say for me, that was crazy. And I'm really proud that we managed to pull this off. Now, I have to say, the clinical trial got cut off because of COVID, which I don't love. But we did treat some patients and we got some amazing results. A company came out of this, which is going to push forward, which I'm so grateful for, Laura Toward and Vivan, who's going to really push this technology forward. And they're doing just an insane job. They're taking this much further. So everybody has pitched into this now, and I should say, I have licensing agreements with them, so I can make money off of events. So I apologize for bringing them up, but I want to be honest about your question, which is also flies are going to need to move into the private sector because that's where a lot of innovation is happening now, and you can see that with small biotechs like Vivan and other ones. So it's a long answer to your question. But I feel like flies are poised to walk forward, handle big data, deal with whole animal answers to people's problems in a way that's going to be tough to replicate for a while.
I want to move maybe to a personal part or personal area, because we see all this passion and all this love of your job, of your work. And I want to ask you, Ross, how come you become scientist? Is that feeling, or is that a hobby? Because for me, it's a hobby. Was with you from the beginning, from your childhood, or it just came when you was in school and college, and doing PhD, etc. So you was like this from the beginning, from your childhood, or not? This is actually my question.
So first of all, Rocco, a hobby for you? I kind of doubt it. We've chatted. Okay, I see the passion. And come on. But all right, so let's talk about me again, since it's my job here. But you and I will have that chat again. So I wanted to be a scientist since I was a little kid. Okay, that is the honest truth. And part of that was like a lot of socially awkward kids, I made my face by how smart I was, right? So I couldn't make my face by how popular I was because I wasn't. So my social currency was, hey, look, I'm a smart guy. And it was pretty nerdy and that sort of thing, which, you know, in Trenton, New Jersey was kind of hard to do. You probably don't know Trenton, but it wasn't the, shall we say, it wasn't the, you know, nicest, wealthiest area. It's a famously tough town. So anyway, but because of those reasons, and because I just liked, you know, looking under rocks and stuff like that, I was pretty obsessed with being a scientist. Now, that went on long enough that even I got bored of it by the time I hit college. So I started to get into music more, had a band there, and thought, okay, forget science, let's do the music thing. And then I found out what the music life is like, and all of that magic hit reality. Part of it was, you know, difficulty, but part of it was, and this goes back a little bit more to your question also, part of it was the musicians I met basically had the idea of, I can say anything I want. I can say, hey, look, this is a spoon. And it's right because I'm super creative and I get to say that. And I thought, that's not right. It's not a spoon. You can't just make stuff up. That's not creativity. That's just making stuff up. So I didn't love that part of it. I realized I liked a little bit of rigor in the way that we do our creativity. So for me, science is art, but they pay you to do it, and there are like rules that force you to hew to it, but otherwise it's art as well. And you know, after doing really great in the music scene, I flipped back, started to look at graduate schools. In those days, you didn't apply to programs, you basically applied to labs. And so I found, someone explained to me, a guy named Shishin, who went on to be a professor at Yale. But he was at University of Chicago when I was there. He was a postdoc, I was an undergrad. And he explained to me, this shows you how old I am. He said, there's this new thing coming called molecular biology, and it's going to be big, okay? And if you can find a genetic system to connect to it, that will be powerful, which is pretty insightful, I have to say. And giving that wisdom to an undergrad was kind of blowing my mind. And so I thought about that and I thought, yeah, that makes sense. And actually a lot of the molecular biology was being worked out in flies. So when I went to visit my parents in Trenton, New Jersey, the closest university there was Princeton. And so I went and visited Don Reddy, a professor there. We hit it off, and the rest is history. I became a dyed-in-the-wool flyboy and kind of haven't looked back. But that's what got me, was the idea that, first of all, I love the rigor of science. Second of all, big data, which we didn't call it then, but big data was coming, right? You could see it coming, and you needed a way to turn that into like real world biology. That's what caused me to get back into science and to walk the path of flies.
Well, actually, my next question was already, I think, discussed, but it will be like a conclusion, because we saw love, we felt enthusiasm also, and we saw this, interconnection between what is you and what is science, and this match between the person and the environment. Is your job useful?
Is my job useful?
Do you think you're such?
So first of all, sure. Well, no, I think it's really important. So there was I don't know who first said it. I heard it from Jerry Rubin, who was quoting somebody that I can't remember, which was the erasure, the measure, which is if you went away and all your work went away, would the world be different? Which is a little bit of what you're asking, right? And I think about that a lot. That actually motivates a lot of how I try to think about things. And people in the lab probably are sick of me saying versions of that. And also, let me link the last question to this question by saying, and talking about how I got into it and the path I've walked, I should also acknowledge the privilege that I've had all the way through. So being born in the right country, in the right situation, and I've had people mentor me. I've had chances to succeed over and over again until finally, I think we've done all right. But I definitely acknowledge that privilege and am grateful for it, and would like to see, of course, everybody have at least some of that. So to your question about, is what we do important? We're trying. I'm grateful to think that there are people alive who had medullary thyroid carcinoma who maybe wouldn't have been, and we weren't the only one. We didn't discover it and spring it on the world. We were just part of the groups that identified it. But still, we did play a role in that, and I'm really grateful for that. I think that our role has been a little bit of a gadfly in the disease world and saying, hey, wait a minute, maybe you should be making drugs that hit many targets. Maybe you should be thinking about bringing in passengers. So I think we do play a role in helping put the brakes on assumptions that people make. Okay, I think that is important. And most importantly, I would say that, and it has colored a lot of me moving forward. I know my lab and I have taken some criticism for our jump into disease, at least early on. I remember when they were doing clinical trials on vandetanib, what's now called vandetanib, it was ZD6474 in those days. And some of the clinical trials were done at WashU Medical School, which is where I was a young professor. And a friend of mine, Tom Baranski, was helping run some of the trials at WashU. And he was about to meet with a woman in her 20s. She had medullary thyroid carcinoma. So a quarter of the patients inherited it. She had a son who also had it, who was with her. And she was taking vandetanib and was actually doing quite well. And so Tom was about to see her as just a follow-up. And he said, would you like to meet her? And he talked to her and she said, yeah, she'd like to meet me. And I sat down with her and we started to talk, and she told me what it was like to grow up with this cancer. And the fact that her, I think he was a 6-year-old son, had the same tumor. You have an even chance of getting it. And that now she was so grateful that there was something they could treat him with. And she was crying and I was crying. And it just made me feel like, yeah, sometimes what we do, we lose track of, that it impacts real people. But I am happy to say that the things we do in our lab, we try to keep an eye on what actually happens with people. I've talked to a lot of patients. So how has that changed what we've done? We don't just try to make drugs that crush tumors. We try to make drugs that don't make people sick, less toxic, because the people have told me what it's like to be treated with cancer. And I kind of knew that, but I kind of didn't know that. And to learn about things like chemo brain, stuff like that, that stuff sucks. And so we spend a lot of time thinking about making better drugs in the sense that they're less toxic, these sorts of things. So to answer your question, I don't know that we've changed everybody's life, but I feel like we're on a good path. I feel good about what we're doing. The people in the laboratory, I hope, feel good about the fact that what they're doing really impacts people. And there are many ways to get into science, going really basic and trying to uncover truths. We've done a lot of that early in my career. But right now, I'm really happy to be able to say that we're, aiming straight at people's lives, and I feel good about that.
Ross, what I'm sure about is one of the utility of this video will be that you add some humanity to a scientist figure. So we are not only people that work in a laboratory with a white coat and, with our microscope, but we are also human. And one of our main goals is to help people and to make this world better. Ross Cagan, again, thank you very much. It was a wonderful interview. Merci beaucoup, as we said. And in Tunisian, we said, يعيشك, which means may God give you a lot of healthy life, or plutôt, may God give you a healthy life. This is actually literally what means thank you in Tunisian, which is, I think, a poetic way to say thank you. Ross, merci beaucoup.
Merci beaucoup. And Rocco, as always, it was lovely to see you. Thanks for the interview.
Hey, c'était bon ça, t'as vu? Merci tout le monde. On revient bientôt. Abonne-toi, jette ton pouce, partage, fais ce que t'as à faire.